Hello and welcome to the 16th video in the Introduction to our workshop series accompanying videos. This workshop series run by QIMR Birkhofer's Statistics Unit. We've talked about what the Statistics Unit offers in previous videos, but there it is again, as well as our contact details. In today's video, because we're going to be focusing on ggplot, obviously you'll need the ggplot2 package installed. And you'll also need, we will be using a little bit of dplyr and magrittr and possibly a little bit of tidyr as well, just to show how they can all work together. We will also be using the wk5_office_bakers_ggplot_data.csv file. That's the data set we'll be working with. Again, you don't have to follow along if you don't want to, but if you want to copy the examples we're doing in the video, be good to download that data set and know where you saved it, so that folder can be set as your working directory. So this video is one of the last releases that are being filmed at this moment. We may do more at another time, but this will be the last one, potentially for a while. So this is the last bit of Into the Tidyverse, where we're looking just at the start of section 23.1 in the booklet, and that's on ggplot. More specifically, ggplot2, as the package is called. Now, ggplot2 and ggplot in general has a good reputation for making visually compelling and complex, but also simple to understand plots. So it can be very dynamic and very high quality. And so it is quite well known for that. Interestingly, the GG in ggplot2 or ggplot stands for Grammar of Graphics. So this is a callback to a lot of data visualization theory, where a lot of work went into how to talk about making a good graphic and what's the basic elements of a good graphic, a good plot. So it's really starting from that point of view to understand where the basics are. Because of this, it can seem a little complicated. When you start using ggplot, it feels unnecessary. You might feel like there's some unnecessary steps, or there'd be ways to break it down to really quick ways to do it. But ggplot, much like the tidyverse in general, is all about having a consistent language in which to talk about and control and move data. So like previous ones, like dplyr talk, there's a lot of ways of wrangling and manipulating data to make it do what you want. In ggplot, it's ways to tell your data what to do to tell a correct story. And there's many different options from that because you can have that control. So it can seem a little complicated to begin with, but once you get used to it, it can be quite easy. So as I said, ggplot comes from the Grammar of Graphics. And one of the theories there is that good data visualization comes basically from the elements of scales and layers. So in a plot, you have different aspects of that plot that can help describe variation in a variable. This might be an X or a Y axis being used to show the scale of a quantitative variable. It might be things like color or shape or size. Those scales of what different parts of that scale mean in terms of quantity or category is one of the basic elements. And then the other element is layers. So these are the plot aspects that help identify what the plot is. So this might be dot points, it might be lines, it might be different ways to present the data that is on those scales. So that's essentially how ggplot works. All plots start with a ggplot function. So there's the ggplot bracket function. In that function, you define the base, data, and aesthetics for the plot. So you've got your data set that you're going in that's going to be plotted. You can add other data sets on top of that in other layers, but we'll get up to that potentially later. But you've got your main data set that you're putting into the plot, and your aesthetics describe the plot, and they describe the scales of the plot. The aesthetics go in an AES function. I'll show you examples of this soon. But the aesthetics go into that AES function. so that ggplot can understand what they're doing. And they define the aspects of the plot which represent what variable. So you define which variable is your x-axis, which variable is your y-axis, etc. Then you add layers to describe what the plot is meant to be, whether it's a scatter plot, a line plot, a bar plot, things like that. So the data set we're going to be using is from our favorite office of Bakers from the previous videos. So this is a fictional office of people and data that I made up because I wanted a fun little example. So this is office workers that each bake a cake every month and like to score each other's cake. So because they're eating so much cake, they get a little bit of weight gain. So I've got a fictional data set where some of them go into an exercise program and things like that. And we've got weight gain relative to some baseline value. This is a fairly non-realistic data set. I'm just using it for examples here. People shouldn't let me have fun making up data sets is the message we should take away from this. So this is essentially what our data looks like. We've got group, which is whether the group started an exercise regime or not. We've got the worker, whether the period is the pre-exercise or the post-exercise. Months from baseline, with 0 months there being the baseline value, hence why there's a weight gain of 0 at the baseline value. And we've also got gender of the worker there as well. You can see there's 2 different groups, 6 different workers, a bunch of different periods because there are 10 months post-baseline. We've got that weight gain range, so we can see that the maximum weight gain is 4.5 kilos. And obviously we don't, when we see the 22 for each worker and the 66 for each worker, that's the amount of data we have for each person or each gender there. Oh, sorry. Before we do that, let's jump over to R. Okay. So I already called all my libraries in, but I'll just do it again. So we will be using dplyr, Negrita, and ggplot2 and tidyr. So hopefully we've already installed those using the install.packages function. And then remember, we need to library them in with the library function. I'm going to call in my data set using read.csv as ggplot data. So it pops up here in my environment with my 6 different variables, factors and integers and a number there. And of course, we can inspect the data first, which is what we just did on that PowerPoint slide. Same results as before. But now let's get into ggplot. So as we mentioned just before, the main things ggplot needs is some data. So here we've got data equals ggplot data. And then we need some inputs to define the axes and the scales. So the technical name for this argument of the ggplot function is mapping, because we're mapping different variables to the different scales on the graph. But the input to that mapping argument has to be the output of an AES function. AES standing for aesthetics. So like with all other R functions, we don't need to define the name of the arguments. We can just put them in there as long as they're in the correct order. So generally we just have ggplot brackets, ggplot data, and then the AES function. We don't need to say, we don't need to have mapping, we don't need to have data equals, but I'm just having them in here so that we're aware of what each input is in the order they come in. You will always have to have AES, the function there. And then inside the AES function is where we define generally our axis scales and a few other things. So here we're saying that the x-axis is months and the y-axis is weight gain. So if I've got my cursor there, I'm going to control enter. I can see in my plot window that I have a blank plot. I've got months on the x-axis from 0 up to 10. I've got weight gain on the y-axis. Now, even without plotting any data, ggplot has figured out what size axes these should be. It knows that months ranges from 0 to 10, and that weight gain ranges from 0 to 4.5. So it's making that plot area based on the data we gave it, even though nothing is there. As a side note, while we're here, it's using just the variable names as the labels, the X and Y axis, which we expect from other plots. Also, ggplot by default has this gray background with the white squares. This is a very useful tool in terms of you can see exactly where on a busy plot where values intersect. So for example, I could see exactly where 5 months and 4 kilograms of weight lane intersect to see what values are around that. So it can be a useful way of if your data points are not close to any of the axes, so you can't necessarily pinpoint what the value is closest to maybe. The white lines on the gray background are a good visual tool for lining up with the axis on the other side of the plot. So obviously all we have right now is a blank plot with axis defined by the data set. So we've got scales, but we need layers now. And we add that by using a variety of different geom functions. So the geom point is the function used to create the scatter plot or point data. So what we do is we have our ggplot function like before, but then we have plus, and we're adding layers using the plus. We could have this all on the one line. So we could have geom point, we could move it up to the same line as the ggplot function. That's generally not the convention though. Some people do it that way and they have it all on the one line. Some people like to break their code up so that after each plus it starts a new line and you can see each line is a new thing you're adding or a new thing you're changing. And if you control enter from this top line, I will read the plus and say, all right, I've got to read the next line as well. So I control enter on this. And now ggplot has added all the data to the plot area in points. So all the points are there. So the geom point function, which has no inputs because it is using the data already given to ggplot, the ggplot function. So the ggplot function already contains the data and the scales and what variables are on what scale. So when we add geom point to that code to make this plot, the geom point function knows it's going to use the data sets and scales that are already there. So we don't need to add it again. We can just say geom point, open close brackets. We can add a couple of layers, so we don't just need to add one layer. Lots of layers can be added, so we can add a line between the connecting points. So the way we're going to do that is by using the group aesthetic. So a group aesthetic is how ggplot knows which points to connect to make a line. And to do that, we're going to paste worker and period together. I think we've seen the paste function potentially in one of our early videos. If not, paste is just a good way to combine things, either text with variable values or two variables together really quickly. It's a good little worker function. So I've made that group aesthetic there as well. And by running this line of code, I'll run all 3 lines. And now there are lines going through all the points that have the same worker in the same period, whether that period was pre-exercise or post-exercise, and the worker of each different of the 6 workers. In fact, yeah. So the next thing we're going to do is we're going to do the exact same thing, except we're going to use more of our tidyverse functions. So quite often when we're using ggplot, we've already said we may not use this mapping. We won't name the mapping input. We'll just have the AES function. And because ggplot works really well with tidyverse and all its other functions, often you can just pipe your data in. And because it's the first input onto the ggplot function, if you pipe the data set in, ggplot will know that that's the data set it wants to be using. And how we can use other tidyverse functions with this is that we can get a data set, change it in ways we need, and then pipe that changed data set into ggplot. This means we don't necessarily need to save another data set between each plot. So say each plot, we're technically wanting to use a different data set for each plot. It might be each plot is filtered in a different way or subsetted in a different way. and we didn't want to save a data set for each plot, what we're going to do is we'll manipulate the data set somehow using pipes and using some other functions, and then that output data set will be given to ggplot and it can move on. We're also going to use the unite function, which is coming from another tidyverse package, which is essentially going to do something very similar to paste, where it combines worker and period into a variable called worker period, and we'll use that variable worker period as the group variable. So there, it's making the exact same plot. So that's an example of how we can use various tidyverse functions together to make a ggplot. Now we've got more options are available to us when we're making a ggplot, because it's not just the x scale and the y scale. There's not just groups we can define that we can connect with a line. Like with a lot of plots, we often use other things to denote other information. So these other layers on the plot could be, or other scales on the plot, I'm sorry, could be the shape of the point, the color of the point in the line, the type of line, and there's even other things as well, such as the fill of the point rather than the outside color of the point, how faded the points are. There's lots of different options to convey data through what is presented on the plot. And so if we want some of these scales or these aspects of the plot to reflect change in a variable, we add them to the aesthetics function, so that AES function. So what I'm doing here is I've got ggplot data going into the unite function using pipes to make that worker period variable. Then it's going into ggplot, where in the aesthetics function we have months and weight gain. Group is worker period, which we've just made in the unite function. The color we're going to define by the period being pre-exercise or post-exercise. We're also going to define shape and line type by period as well. So there are all the scales we're using. And then we're going to add the layers of geom point and geom line. So I run that line of code. What I can see here is that my pre-exercise data just consistently rises. So if we're not doing any type of exercise program, each month, because of all the cake the workers are eating, they just gain a little bit of weight. However, with an exercise program, we can see that some of those workers did actually, in fact, start to lose some weight, or not start to lose some weight, sorry, they didn't gain some weight for a short amount of time before they again started gaining some weight with their peers. Another thing we can see from that is even though we've defined the pre-exercise to be circles and the with exercise to be triangles, and the circles are red, the triangles are blue, and the pre-exercise has a solid line and the with exercise has a dashed line. These are all combined into the one legend. So because the legend is on the same variable and it's just using the default name of that variable, ggplot will combine it all into the one legend, which is a very handy thing to do. We haven't, in this example, we haven't changed any of the defaults. We haven't changed default labels. We haven't changed default values for the scales. This isn't going to be part of this video. This video is just covering the basics. Those types of things will also be in the booklet, so I encourage you to check that out. But just as an example, if we have other variables being put onto scales as well, so say in this next example, shape we're actually making worker, and line type we're making gender. So what happens when we run that code is that a legend is made for each scale we've created. So gender here is the line type. So it said that female is a solid line and male is a dashed line or dotted line. Each worker has its own different shape, and these are just the default shapes that will pop up if you don't tell ggplot exactly which shapes you want to use. Again, we're not covering that in this video. We have the booklet there, and the internet is available to you. And then like before, period is defined by the colors. So red for pre-exercise and blue for with exercise. So this is essentially the very basics of ggplot. There's obviously a lot to ggplot. There's a lot more we could cover in a video, There's a lot more that we do cover actually in the book, so I encourage you to check out the book, check out the exercises and activities in there and the examples. But the main part from this video is just to understand the basics, so that if you do go to try and make a plot in ggplot and you might find some code online that makes something similar, you kind of understand what's happening so you can figure out how to change it. And you probably do that by understanding the basics of, within the ggplot function, you start with a data set, and then you have an aesthetics function where you define the variables that are going to scales in your data on your plot. And then you have layers that you add which define what the plot is going to look like. They're the basics of ggplot. So thank you very much for watching. We really hope you've learned something from all these videos. We really hope you come along to a workshop if you haven't already. And please let us know if you've got any feedback. Thank you very much. And just remember, the best way to learn R is by doing R.